Hi, welcome back to the Real Numbers course. We haven't said this in a while, but remember, the real numbers are the integers and all the numbers in between. And today, we're going to continue our study of some of the numbers in between, the fractions. So remember, fractions are numbers. And I think we've got a pretty good handle on these numbers so far. Like for example, if someone says, "Hey, can you give me 2 glasses of water?" Okay, yeah, I can picture that in my head. But now if someone says, "Hey, could you give me 2/3 of a glass of water?" I can also picture that. I got that under control, and I bet you do too. Someone could say, "Hey, I went out for a 3-mile run this morning," and we can understand what that means. But now someone could also say, "Hey, I went for a run of 3/8 miles." And we also totally understand that. So we're in pretty good shape. Today, we'll deepen that. There are 3 sort of basic things, basic ideas that we need to have under our belt. And let's address those today. For example, having a number sense of when a fraction is close to 0 or close to 1 is going to turn out to be pretty important. Like if we're talking fifths, let's say, I think you probably have a really good understanding of like 3/5 or 4/5, stuff like that, numbers like that. What about 5/5? What do you think that means? Well, if we just do what we normally do with our fractions, take that bar, split it up into 5 equal pieces, but we keep all 5 of the fifths, well, we've got the whole bar. In fact, we've got 1 bar. 5/5 is just 1. That's a way to write 1. Making sense? What if we had 0/5? Well, we wouldn't shade in any of those bars, would we? 5 equal pieces, we keep 0 of them. Guys, 0/5 is 0. All right. Now, there's nothing special about fifths. Okay, I don't want to give you the wrong impression. What if we were dealing with 13/13ths? Well, that's just going to be 1 as well, right? 13 equal pieces, keep them all, we're good to go. Okay, 13/13ths is 1. And by the way, just for later, 20/20ths is 1, 50/50ths is 1, 37/37ths is 1, 100% is 1. Okay, but 13/13ths equals 1. And of course, 0/13ths, that's just 0. Here, let's push this a little bit though. What if I wanted to put in a numerator here that would make a fraction that's close to 1? That's close to 1. Well, here's our 13ths. I want to get close to 1. What if we chose 12/13ths? That'd be close to 1, wouldn't it? Here's our shading. Look at that. 12/13ths is almost 1. It's almost the whole bar. 1 bar. I guess we could also do, if we wanted to, 11/13ths, right? That's also kind of close to 1. But probably 12/13ths is the way to go. That's as close as we can get with those 13ths, full 13ths. All right, let's do the same thing. What if we had this fraction and we wanted to pick the numerator so that we would be really close to 0? Well, there's our 13ths again. What if we just had 1/13th? What if we only shaded in one of them? That would be really close to 0, wouldn't it? Almost like nothing. Okay, imagine you got a candy bar and you just take a little 13th of it. It's like, okay, thanks, but that's not much. It's almost 0. All right, very nice. So that's important. Close to 1, close to 0. Okay, you want to have a good handle on that. Here's another important idea: leftovers. So I'll give you an example to make sense of this. Let's say you eat 7/9 of a candy bar. How much would you have left? All right, now you might even be able to see it just with the numbers in the fraction, but here's a visual just to help us get started. All right, there's our candy bar. We're going to eat. So get ready. We're going to eat 7/9. So there's 9 equal pieces. We split it up. We're talking ninths. Let's eat 7 of them. I'll spare you the sound effects. There. Okay, we ate 7/9 of the candy bar. And look what's left. We have just 2/9 left, right? Sort of seeing how that works? 9 equal pieces. We've taken away 7. What we have left is 2. 2/9. All right, so we've got 2/9 left over. All right. Okay, here's another example. A crew has paved 87% of a road. How much do they have left to pave? Well, again, this is important now. We haven't said this in a little while. Remember, 87% is really just a way of saying 87 hundredths, right? Percent means hundredths. So, all right, we understand this. Here's a visual to help. Even if you're seeing it in the numbers, which is great, but just one more time with the visual. Here's the road. Okay, there's one whole road. 87%. Now I'm going to benchmark this one. So there's 0 pieces. There's the 100th piece. Here's our famous benchmark. Halfway, that would be the 50th piece. Okay, let me do one more half benchmark like we've done. It's 25. That's what the 25th piece would be. So 25, 50, 75. And now 87, that would be, let's see, 12 more hundredths to the right of 75. So I'll put that down there. It's almost halfway between 75 and 100, isn't it? And that would be where 87, the 87th piece, the 87 hundredth would end. So let's shade up, and that's them paving. All right. Now look, what do we have left to pave, or what do they have left to pave? So 87 up to 100. So let's see, 3 more pieces would get us to 90. And then from 90 to 100, that's 10 more. So 3 and then 10, 13 hundredths left. Making sense? 13 hundredths. By the way, 13 hundredths is 13%. By the way, we all often call these complements. Like what does it take to complete the whole thing? All right, so 13% is what we have left over, or the complement of 87%. All right, looking good? All right, one more big idea. Half. We've seen this already in this video over and over again. Half is a really important benchmark. So if you want to know whether your number is less than a half or bigger than a half, that's gonna be really important to be able to do quickly. All you really need to know is what is half in your situation. So for example, if you need to know, is 5/8 less than or greater than 1/2? It comes down to just figuring out what a half is when you're talking eighths. So here's a quick visual. Got our bar. We do 8 equal pieces. If we split it right down the middle, that's half, isn't it? That's half the bar. And you can see half would mean we have 4/8, right? 4/8. You guys seeing how we get that quickly in the numbers? Good. Just take 8 and divide it by 2. That's 4. So 4/8 equals 1/2. And once you understand that, now it's easy to compare. 5/8 is more than 4/8. So 5/8 is more than 1/2. It's greater than 1/2. So is 6/8, 7/8, etc. Looking okay? So if you want to compare to a half, first figure out what half is in your particular situation. All right? Here's another one. What if you wanted to compare 9/20ths to a half? All right, well, let's do the same thing. We need to figure out what half is when you're talking 20ths. And this sounds like a great application of our benchmarking. Just like before, there they are. Cut it right in half. There's the magic half line. And we can see 20 divided by 2, 10. All right, now we got it. Now to compare 9/20ths to 10/20ths is a pretty easy thing to do. So 9/20ths has to be less than 10/20ths, of course. So 9/20ths is less than a half. See how that's working? Just figure out what half is, and then you're good to go. All right. Here's one more. Let's maybe do this without the bars. I don't know. Let's see. 25/46. You want to know if this is less than or greater than a half. All right, so maybe unlike the first couple, maybe 46 cutting that in half, maybe you can't do that in your head. Don't worry. You can always just come off to the side and do that division. Just divide 46 by 2. And that's going to be, let's see, 2 goes into 4 2 times. 2 into 6 goes 3 times. Okay, good. 23. So you can just compute it off to the side if you need to, if you can't see it. All right, so 23/46 is equal to 1/2. And now we can compare our fraction. All right, so 23/46 is half. 25/46 is more. So 25/46 is greater than 1/2. Looking okay? All right, good. Now it does get a little bit more complicated, not much, if the denominator is odd. Okay, but no big deal. Check this out. Is 4/7 less than or greater than 1/2? All right, so what we need to do is figure out what half is, again, when we're talking sevens. Well, here's just a quick visual to help with this. 7 divided by 2. Well, if you got the bar, you split it up into 7 equal pieces. Let me just slice it right down the middle. If you notice, half of 7 pieces is 3 and a half of another bar. It's 3 1/2. Half of 7 is 3 plus another half of a bar. No problem. I don't know if you guys have ever seen this. Let me just show you. 7 divided by 2. 2 goes into 7 3 times, right? That's 6. And we have this remainder of 1. Well, let's push it a little bit. We're not just going to say remainder. This 1, it's really related to what we're dividing by. So it's 3 and 1/2 there. All right, we'll talk about that a little bit more later. The visual can help you see that. So 3 1/2 sevenths is what 1/2 looks like. There we go. So 4 7ths is clearly more than a half. All right. That's what I meant about it getting a little bit more involved with that odd denominator, but you'll get it. You'll have time to practice that. No problem. Here, I'll give you one more to try just to make sure it's looking good. How about 13/27ths? Well, let's do it. Let's divide 27 by 2. All right, let's see. It goes in 1 time there, 0 there. Goes 3 times. Subtract it, we get 1. 13 1/2 is the magic number of 27ths. So 13 1/2 27ths, that's what 1/2 looks like. So, all right, well, 13 is less than 13 and another half, isn't it? So 13/27ths is less than a half. All right, you have plenty of time to practice bunches of problems to get that really strong. Those are 3 really important basic ideas, okay? I think we'll call it a day for today. I'll let you get to work on this stuff on your own or with your TAs. Have a great rest of the day, and I'll catch you in our next lesson. Bye, guys.